civil engineering. Today we are going to conduct this tension test on steel bar. Right? So before testing, we need some of the apparatus. That is like tape, one scale, vernier caliper, and a steel bar. Obviously, your team is needed. Right? Now, what you have to do is first you have to find out the total length of the specimen. So if I calculate this, the total length of the specimen is 76 centimeter, right? 76 centimeter, and use vernier caliper to find out the diameter of the steel bar. Obviously, it will be given in your bar what is the diameter, but verify it using vernier caliper. So this is a 16 mm dia bar. What you have to do first? You have to find out the gauge length for this bar. So according to IS 1786-2008, the formula for gauge length is 5.65 root over A. A is nothing but area. So if I calculate it, I will get the gauge length nearly 80 mm. Okay, I will get the gauge length 80 mm. Now what you have to do? Mark the center point of the rock. So you can see here, this is my center point. This is my center point of the bar. And from here, I am marking 40 mm this side, 40 mm this side. So this will be my gauge length. This will be my gauge length for the bar. And here I mark something, and here I mark something. What is this 2? This 2 is like this much portion of the bar, and this much portion of the bar will be fixed to the jacks. Now here you can see that this is the fixed upper jack. That top one is the fixed upper jack, and this middle one is the movable jack. So what we are going to do? We are going to fix this specimen at the upper jack and at the middle jack. What happened? This upper jack is fixed, and we are going to pull this or give the tension like when the middle jack moves downwards. So the middle jack is the movable jack. It can move up, it can move down. So what you have to do? Fix it here and pull it from this end. Okay? So this is how we will conduct the test, and when it is moving down or when the tension is applied in this bar, as you can see here, there is a scale. Using this scale, we are going to find out the extension in the bar. Actually speaking, we need to use extensometer for calculating or for finding out the deformation, or you can say elongation, but here we are going to use this scale. Coming to the loading, here you can see this is the dial gauge, this is the loading unit. From here we are going to give the load. So here you can see 100, 200, 300, like that we have up to 1000. Right? So each division here it is given as 2 kilonewton, and here we are going to find out for each 5 mm extension what is the load carried by this bar. Okay, so here there are 2 needles. One is the black needle, another one is the red needle. The black needle is the loading needle, and the red one is called as dummy needle. Dummy means it will follow the black. Right? So how we are going to conduct this test? Let's see. Okay, so now we are going to fix the bar in the jaw of the uterus. See, there we have fixed it at the top jaw. Now at the middle jaw should also be tightened at the bottom end of the specimen. So here there is a button. Buttons are there in the uterium. So if I press the up button, the middle jaw will move in upward direction. So this is how we will fix the specimen in the uterus. now it is ready to give the right. So now let's start the loading. So before loading, make sure both the needle here is at the starting point, that is 0, here 1000 and 0 is coinciding, so it is at the 0. Now let's switch on the machine. Before switching on, you need to see that this valve should be open and this is closed completely. Okay? Yes, this is should be closed, so this should be open and this valve should be closed. Now, once you switch on the machine, what you have to do? First you have to close this valve and this will be your load valve. What you have to do? You have to slowly, gradually give the load to the spacer. So let's do it. So I am switching on, and after switching on, first thing is to close this valve. Once I close this valve, now let's start giving the load gradually. So here I am giving the load gradually. So you have to give slowly the load, gradual increment of the loads here. And at the initial point, you will not find any extension in the scale. Why? Because the extension is very less at the initial point. So that is why we need to put the extensometer in the specimen. But as we keep on increasing the load slowly, we can find the extension in the scale also. So I am increasing slowly. Now you can see here, previously the needle is at 0, now it is slightly coming down. So the extension is visible now. Like in the scale we can see the bar is getting elongated slowly. Now you can see only hardly there is 0.4 mm of extension. So as we keep on increasing the load, the extension will slowly increase. So here you can see there is a significant extension in the rod, that is about 20 mm. Now here we are going to increase the load further and see what is going to happen. Right, as you can see, the neck formation is visible now, and any time from now it can going to break. So as soon as I increase the load, you can see the black needle is starting to going back and it fails. As you can see here in the scale, the elongation happened in the bar is almost 65 mm. 65 mm. Right? Now coming to the dial gauge, you can see the red needle is stopped here and the black needle went back. Why black needle went back? Because this is the loading needle. So this red needle is showing us the ultimate load in the bar, or the ultimate load taken by the bar. And when it starts, when the point where it breaks is the point where I mark with a chalk. So this is your failure load. The red needle showing is the ultimate load, and this mark is showing the failure load. So this is how we conduct tension test on mind scale, and later we will calculate the yield strength, the ultimate strength, and percentage of elongation. So you can see this is the specimen after breaking. So this is your cone and this is your cup. So cup cone failure occur. Now we have to calculate what is the percentage of elongation. So you can see our previous marking showing us the so this is our previous marking. This is the gauge length before. Now it is increased. So what is our final gauge length? Previous gauge length, if you remember, it is 80 mm, right? And the final gauge length is now, you can see it is almost 10.5 centimeter. 10.5 centimeter means 100.5 mm. Okay, so final gauge length is 100.5 mm. Initial is 80 mm. So percentage elongation will be 100.5 minus 80 divided by 80. So percentage elongation will be 25.6%. Right. So with this we have completed the tension test on steel piece.